Bowl of Data, the podcast. The walls we thought were solid are starting to look a lot more like paper. We are seeing a massive shift where the rapid advancement of AI-driven automated reasoning is effectively neutralizing traditional security boundaries and accelerating the timeline for cryptographic obsolescence. It is not just about smarter chatbots anymore. It is about autonomous systems that can reverse engineer complex mathematical protections faster than we can patch them. I am Marco, and this is Bowl of Data. This week, we are looking at a landscape where secrecy is becoming harder to maintain, from quantum breakthroughs that bypass zero-knowledge proofs to AI agents that can leak entire private repositories just by reading a single public issue. The era of assuming your encryption will hold for the next decade is officially over. The idea that you could hide a breakthrough behind a zero-knowledge proof to prevent widespread panic just failed spectacularly. Google researchers recently found a way to break 256-bit elliptic curve cryptography, which is basically the bedrock of modern internet and crypto security, using only about 1/400 logical qubits. To avoid handing a roadmap to attackers, they used zero-knowledge proofs to verify their findings without revealing exactly how they did it. It was a clever attempt at responsible disclosure, but the startup Agentic Labs essentially treated that secrecy as a challenge. They deployed a swarm of autonomous AI agents and crowdsourced scientific analysis to reverse engineer Google's hidden methodology. The results were terrifyingly efficient. Within just 72 hours, Agentic Labs matched Google's results, and by the third day, they had developed a quantum circuit that was nearly 48% more efficient than Google's original discovery. This is a massive signal that automated cryptanalysis is moving faster than human-led security research. When AI agents can optimize attacks in days rather than months, the window for preparing our defenses shrinks to almost nothing. That efficiency gain of nearly 50% is exactly why the industry's timeline for quantum safety just got pulled forward. We are no longer looking at a distant 2030 problem. Microsoft, Google, and Cloudflare have all officially moved their target implementation dates for quantum-safe cryptography up to 2029. This acceleration is driven by the realization that cryptographically relevant quantum computers might arrive much sooner than anyone predicted. One of the biggest drivers is something called the harvest now, decrypt later strategy. Adversaries are currently intercepting and stockpiling massive amounts of encrypted data today, betting that they can simply unlock it once they have the hardware. Even if we are still in the NISQ era with chips like IBM Heron or Google Willow, the progress in neutral atom architectures means the threat is real right now. For engineers, this means the transition to post-quantum standards is not a future roadmap item, it is an active engineering requirement. You need to be building for crypto agility today, ensuring that your systems can swap out algorithms like RSA or ECC for lattice-based structures without requiring a complete architectural overhaul. The era of set it and forget it encryption is dead. While everyone is worried about quantum computers breaking math, there is a much more immediate threat coming from the very AI agents we are integrating into our daily workflows. Researchers at Noma Labs just uncovered a vulnerability called GitLost, which targets GitHub's new agentic workflows. These workflows use models like Claude and Copilot to automate tasks by reading through repository content. The flaw is an indirect prompt injection, because the agent treats user-generated text like a public issue or comment. As part of its trusted instruction set, an attacker can simply open a public issue with malicious commands. They can trick the agent into fetching files from your private, sensitive repositories and posting them back to a public thread. What is truly wild is how easy it was to bypass GitHub's own guardrails. The researchers found that they could bypass detection using nothing more than simple linguistic triggers, specifically just adding the word additionally to their instructions to reframe the model's logic. It proves that we cannot treat the context window as a safe space. If your agent is reading untrusted user input, you are essentially giving every commenter in a public repo a direct line to your internal codebase. The ease with which that simple word additionally bypassed security highlights a massive gap in how we handle model reasoning and instruction following. This same struggle with managing how models learn and generalize is being addressed in a new paper on direct on-policy distillation, or DirectOPD. The researchers are tackling the bottleneck of transferring complex reasoning from giant teacher models to smaller, more efficient students. Instead of trying to make the student mimic the entire absolute policy of the teacher, which often leads to a performance ceiling, DirectOPD focuses only on distilling the policy shift created by reinforcement learning. It is a smarter way to achieve weak-to-strong generalization without the student getting overwhelmed by the sheer scale of the teacher's knowledge. If we can successfully distill that reasoning into smaller models, it leads directly into the massive wave of new, high-efficiency releases we are seeing from NVIDIA and StepFun. NVIDIA just dropped Nematron 3 Ultra, which is hitting benchmark-leading performance while operating at 1/10 the inference cost of its competitors by optimizing the LangChain Deep Agents harness. At the same time, StepFun released Step 3, 7 Flash, a massive 198 billion parameter Mo-E model built for high-frequency production. It can hit up to 400 tokens per second and is specifically designed for the kind of agentic workflows that are currently so vulnerable to injection attacks. Between NVIDIA cost efficiency and Anthropic's transition of Claude code into a fully autonomous coding agent, the industry is clearly racing toward a future where agents are ubiquitous, fast, and incredibly cheap to run. As we move toward a world of 400 tokens per second and autonomous coding agents, the focus has to shift from just making models smarter to making them more resilient. Whether it is protecting against quantum decryption or securing our agentic pipelines against prompt injection, the engineering challenge of the next 3 years is going to be about boundaries and trust. We have the speed, now we need the stability. Thanks for listening. You can find the full write-up on all these stories in this week's newsletter. That's the bowl for this week.